Good day, this is Jim Pytel from Columbia Gorge Community College, Renewable Energy Technology Program. This is EET 122, Digital 2. Today we're going to discuss the traffic signal control, part 1 in the system application activity in your book. This right here is an introduction to state diagrams. All we're actually going to use is, all we're going to develop is the combinational logic portion of it. We're going to worry about the sequential and timing stuff later. But this is a really, really good introduction to state diagrams. How you get those sequences, we'll figure out later, but pretty nice introduction to state diagrams. Well, the problem is here, you've got a main street and side street. And Main Street's super busy, side street is not so busy, but it's busy enough to warrant a traffic control device right in the center. And just think about any traffic light you've ever run across. Ideally, when you look at the traffic light, you should only be seeing one signal at a time. If you saw a red and a green simultaneously, that would be a bad design for a traffic light. So, and ideally, you're only seeing your signal. So if you're on Main Street and your car is right here, what you're seeing is this. And if you're on side street, you're seeing that. Okay, so what I've done is drawn Main Street, how you view it from Main Street, and how you view it from the side street. Main, side. And if you think about it, there's a logical progression between states, and that's what these are. These are states that just signify, okay, main is going to have one output and side's going to have one output. And let's just talk about the basic one. Okay, Main Street, since it's super busy, it's going to be green. Side street's going to be red. And we're going to have that state for at least 25 seconds, or as long as there's no car in the side street, because why would you switch to the next state if there was no cars waiting on the side street? But if some car does pull up on the side street and 25 seconds has passed, we want to give this guy a chance on the side street to finally go through. So what's the next state? Well, warn everybody in the Main Street that the light's about to change. Keep that guy from going. And how long do you want to warn him? Well, let's warn him for at least 4 seconds. We're transitioning from that state to the next state. Okay, now everybody's been warned on Main Street that the light's about to change. And it changes, it's red, and it switches to green. Now he's good to go, and he can actually cross right there. So it's transitioned from the second state to the third state. And what's our fourth state there? Well, we give the guy 25 seconds to pass. Again, don't dilly-dally at that light. You only got 25 seconds. Or if there's no other vehicle on the side street, just why would you keep it green? So 25 seconds max. Min. What we're going to do is we're going to switch. Now we're going to say, okay, hurry up, side streeters, because the light is about to change. We're going to keep that main red. And then what are we going to go back to? This guy right there. So it's this kind of looping sequence where you're going from state 1 to 2 to 3 to 4. Oh, by the way, 4 seconds for this timer too, for that yellow light. Give everybody a chance to see it. And again, we're not getting a situation where we're ever getting 2 lights lit on any particular direction. That would be bad. Okay, so this is kind of the setup for a state diagram. So this is kind of the general picture, but before we go into the state diagram, I just want to refresh you guys' memory about the gray code. Okay, so remember binary. If we count in binary, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, and so on and so forth. Gray code, remember? only one bit changes at a time. So 0, 0, 0, 1, that's still only one bit has changed because that jumped up to a 1. But now, what's the third state in a gray code? Well, it's 1, 1, because this guy hasn't changed, but this guy did. And now, what's the fourth state in gray code? 1, 0. And this guy changes, okay? And if you remember right, that's what we used in our K-maps. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Basically, what you're setting up here is a situation where there's only one thing that's changing, one bit that's changing at a time. So, a little refresher on gray code versus binary. Okay, so first thing to do in a state diagram, just and you're going to get a lot of practice of these. Just let's draw one real quick. I don't know why they use circles, but they always do. Let's just name our states 0, 0. Now we're going to count up using gray code 0, 1, and we're going to count up using gray code 1, 1. So a little different than binary. Count up using gray code 1, 0. And we're transitioning from state 1, our first state, to our second state, to our third state, to our fourth state, and back to the first state, just like right here. So first to second, second to third, third to fourth, fourth back to first. Okay? And what is the conditions? What's the what's the output for the first state? Well, the main is green, the side is red. So I'm going to say MS, green, red. What's the outputs for state 2? Well, the main is yellow, side state still red. What's the output for the third state? Well, now the main is red, side is green. Output for the fourth state here, this is going to be red still, and then the side is changing yellow, and it switches over back to our first state. So first to second to third to fourth, have we done everything correctly? Yes, we have. Okay, now there is another condition here though. Remember our timers. So if you're in the first state, there's a condition here about 25 seconds, right? So as long as 25 seconds haven't passed, you're going to be staying in that state. So what we should do is draw another arrow. And basically what this is signifying is it's going to come back to that state. And we'll worry about the logic for that in a little bit. Same thing here is our second state, remember. We want to stay there for 4 seconds. Previously, it was 25 seconds for the first one. Second state was 4 seconds. So we're going to have this thing where we come out and come back into that state for 4 seconds. This next one, we want to keep that for a minimum of 25 seconds. So we're going to come out of that state and come back into it. Basically, we haven't progressed. We're staying in that spot because of the timer. Okay, and now this last one right here is, it says stay that way, stay yellow on the side street and red on the main for at least 4 seconds. So we're staying there for at least 4 seconds. Okay, that's the general picture of what a state diagram would look like. But now, what's happening is basically there's, transition from kindergarten to first grade. You've got to you have to put your blocks in order. There's certain graduation requirements, So think about these arrows as little hoops you got to jump through. They're graduation requirements. You got to be able to play with your blocks to move on to first grade. You got to be able to eat paste to move on to second grade. So think about these things are just little graduation requirements. Well, what's the graduation requirement for something in the first state, which we remember right, was the main was green, the side was red. What's the requirement for it to transition to the second state? Well, there's got to be a car on the side street. Why would you ever change why would you ever change the lights if there's no car on the side street? So that car is definitely in there. That's one of those things. Car's got to be there. But what's the other condition? Well, there's 25 seconds. So 25 seconds has to have passed before we can transition. Okay, so let's call at 25 seconds, we're going to call that variable TL for timer long. Okay, and let's call VS is there's a vehicle on the side street. Okay, and while we're at it, I'm just going to name, actually, no, we'll come back to those other ones. So we know there's TL and VS, those are our requirements to graduate from the first state to the second state. But how do you arrange them? Well, TL, timer, long timer, 25 seconds. So it's high whenever it's between 0 to 25. It's basically implying I'm counting right now. So if it'll give you a 1. So if it gives a 0, it's implying that I'm not counting anymore. So we can go ahead and change. So what's that saying is not TL and a vehicle on the side street. So here is basically, yeah, it's been 45 seconds, but say there's no vehicle on the side street, so you don't change. Or it's been 45 seconds, the IETL is off, and there's a vehicle on the side street, go ahead and transition. Okay, so now what is the transition? So our second state here is our yellow on the main street and red on the side street. What is the conditions for it to change? Well, there's really no vehicle condition, it's just time dependent. And that next variable right here, we're going to put in our variable list is TS. That's our timer, our short timer. So short, that's 4 seconds. That's our long side street, 25. So if it's still counting, that means 4 seconds has not gone by yet. And now it's stopped counting, means we can transition. So anytime it's a 0, we can transition. So all it is just not TS. And that transitioned us to the third state. Now we're in our third state, and our third state is our green on the side street, and our main is red. Okay, so now how do we get out of that one? Well, here is definitely got something to do with a vehicle on the side street, and it's got something to do with TL. How is it arranged? Well, there's got to be no vehicles on the side street, or because it's a minimum, TL, not TL, okay? Because just think about that. If there's no vehicles on the side street, that's a 1. So if VS is 0, then not VS, so 1. So this expression here would be a 1 because it's an OR. And now TL, if TL is 1, implying, hey, I'm still counting 25 seconds here, that's a 0. So give me a chance to change. And then TL, let's say it's a 1. Excuse me, let's say it's a 0. It has stopped counting. A not TL is a 1, so it's also giving us a 1 right there. So give them at least 25 seconds, or let's wait for the thing to clear. We transition to the next. Okay, our third state here is, excuse me, our fourth state. Our fourth state, red on the main, yellow on the side. Not really dependent on vehicles, very similar to this transition here. Well, as a matter of fact, that's the same logic because it's still that same short timer. Okay, so now let's talk about these. Let me clean this up here. Let's talk about these loops. What's going to keep you in those states? Let's just start with the easy ones. Well, these the yellow light conditions, the only time it's going to stay in that state if that short timer, 4 seconds, hasn't passed. So TS. Same thing here, TS. Okay, now let's think about this. Let's think about this top one here. Okay, so what is going to keep that main light green? Well, if there's not a vehicle on the side street, or if long timer is still counting. What's going to keep us in the transition state, keep us in the state 3 here, where the side is green and the main is red? Well, definitely if there's a vehicle in there and if timer long is still counting, okay? So if timer long has stopped counting, it's past 25 seconds, you had your chance, man, it's gonna transition to the fourth state here, okay? So basically, state diagram, it shows these transitions between states, and I'm going to circle those in red because it's getting a little confusing there. So transitions between states and what's going to keep you in states. The states individually, we're going to go back over this in more detail too. This is just the first introduction to it. Is the gray code identifier. And then finally, what are the outputs for each state? So 1, 2, 3, 4. Transition, what's going to keep you, what the state number is in the gray code, and what the outputs are. Okay, now that we've exhausted the state diagram to death here, let's actually talk about the combinational logic that makes this thing happen. So the book has it divided up into 3 separate areas. The combinational logic, which we're actually going to do today, and the sequential, and then our timer. And if you think about it, just ignore sequential and timer for right now. Just say that the sequential for now gives you the gray code. All it does is step from 0, 0 to 0, 1 to 1, 1 to 1, 0. And so it looks like in our 4-state diagram, it's going to require 2 bits. So sequential, it just gives you the gray code. G0, G1. What's our output for our combinational logic? Well, there's 3 lights on the main and 3 lights on the side. So it sounds like there's going to be 6 outputs there. So we've got our main, our red, our yellow, and our green. And our side are red, yellow, and green. So that's going to create, those are our outputs that we're looking for. And then we're going to deal with our triggers too. We'll talk about these in a little bit here. Is our long and our short trigger. And these are going to be fed to our timing circuits. And right here is there's a little bit of some feedback here to the sequential. And by the way, what's this whole what's the big thing that's stepping the sequential logic? It's that guy right there. So it's the vehicle sensor. So that's super important. That's really what's changing a lot of the from sequence to sequence. What's the other inputs? Well, the timers. So TS, TL, and then we have a clock right here, which is basically keeping everybody on the same beat. Okay, so when is the main red? Well, the main is red in state, looks like state 3 and state 4. So state 3 was a 1, 1, and state 4 is 1, 0. So that's our main red. So it looks like state 3 or state 4 that will give us a main red. But we've only got 2 bits here. So what we could do is further, because there's 4 states, but we only got 2 bits coming in. So what we could do is further break up our combinational logic section into something that looks like this, where we have a state decoder. And what is the function of a decoder? I'm going to go ahead and pause it. Well, actually, you go ahead and pause it and think about what is the function of a state decoder. Well, so if you got 2 coming in, you got 4 coming out. Basically, a decoder, what it's doing, it's basically detecting the presence of specific combination on its inputs, and it indicates its presence on one of its outputs. Okay, so let's just do our truth table. That's our gray code. State 4, state 3, state 2, state 1. So 0, 0, what state are we in? We're in state 1. 0, 1, what state are we in? State 2. So it's basically indicating the presence on one and only one of these things. So now G0 is 1, G1 is 1. What state are we at? So if these are both, let's draw actual ones. If that's a 1 and that's a 1, well, this one should be 1. And so on. So now what we can use is using the outputs of the state decoder. So if it was 3 or 4, so main red is equal to S3 or S4. Implying that it's an active high that lights up the red light. So, and you can keep on doing that. Let's just do let's do main light green. So the main light is green, looks like only in state 1. Main green. And when is the main light yellow? Well, it's state 2, and that's it. Main yellow. And you can just keep on doing this. Do these things for the sides. And basically, you're just going to have a mess of these things. And I'm going to replace that mess of things with a big block that says output logic. Where it's feeding the outputs of the state decoder through a bunch of ors, ands, whatever, to our outputs MR, Y, G, SR, Y, and G. And we're going to make another block down here, because what initiates our trigger? Well, those same states. And here's the trigger logic right here. And what is its inputs? Well, it's still the states. So what initiates the long trigger? Well, let's think about it. Got to be in state 1 or state 3. Okay? So you could do a little OR gate between S1 and S3, and that's your long. And what's going to initiate our short? It would also be an OR gate between S2 and S4. And those are all dumped inside that box right there. They're all really super simple logic, by the way. the book has a multi-sim file showing how they've done it. That's not the only way of doing it. And if you have the CD-ROM, there is a multi-sim file that you can actually open up and play around with it. But I think I've got it too. I'll try to post it on the Moodle site too, so that way if you guys don't have it, you can open it up too. But all we're really worried about is just kind of the combinational logic. Just think about here is we used a state decoder. In our sequential was giving us the gray code as it transitions from 1 to 2 to 3 to 4 and back to 1. But what we used was the state decoder here, where it was looking for the combination of certain bits, and it gave us these outputs here. And based off those outputs, we had some logic going to lights, and we had some triggers right here. Okay, not too complicated.